Okay, let's just jump right in. What if I told you that you are surrounded, right now, by literally billions of tiny invisible brains? Seriously, they're in your coffee maker, they're in your car, your TV remote, heck, even your electric toothbrush. These are the real unsung heroes of our digital world, and today we're going to get to know these tiny computers that are secretly running everything. Take a look at this. It might not seem like much, but that little chip, that's a whole computer. It's the hidden intelligence tucked away inside pretty much every electronic device you use. They're not there to browse the web, they have one specific job to do, and they do it silently and perfectly, day in and day out. But what exactly are they? Well, the official name for them is a microcontroller, and the definition is key here. It's a small computer on a single integrated circuit. That word single is everything. See, the computer on your desk has a separate processor, separate memory, separate cards. It's all different pieces. A microcontroller crams all of that, the brain, the memory, and the ways to talk to the real world, onto one tiny piece of silicon. And that is what makes them so small, so cheap, and so incredibly power efficient. It's why we can stick them inside, well, everything. So, if it's a whole computer on a chip, what's actually packed in there? Let's peel back the layers for a second and take a look at the anatomy of a microcontroller. Okay, so at the very center, you've got the CPU, right? That's the brain doing all the processing. Then you've got memory, which holds its to-do list, the program, and any data it's working with. But this next part is what makes them so special, the input-output ports. You can think of these as the chip's senses and its hands. They're how it can feel a button press, see a signal from a sensor, or take action, like lighting up an LED or spinning a motor. Plus, they have other cool tools built right in, like timers to keep track of, well, time, and converters that let them understand real-world things like temperature or sound. But here's the thing. Just like any big family, not all microcontrollers are the same. They come in all sorts of different shapes and sizes with different powers, and engineers have a few key ways to sort them out to make sure they're picking the right tool for the right job. First up is something called bus width. The easiest way to think about this is like lanes on a highway. An 8-bit controller has an 8-lane highway for data to move around. A 32-bit controller? It has a 32-lane superhighway. As you'd guess, the more lanes you have, the more data you can move at once, which usually means way better performance for more complicated tasks. Next up is how they handle their memory. Most microcontrollers use what's called embedded memory. That's what you see on the left. Everything it needs is right there on the chip. It's like a self-contained toolbox. The other way, using external memory, is less common for these guys. That's where the memory chips are separate. It gives you more flexibility if you need a ton of memory, but it kind of defeats the purpose of having everything on one tiny, simple chip. And this brings us to a really fundamental idea in computer design, the instruction set. On one side, you have CISC, which stands for Complex Instruction Set Computer. With CISC, one command can do a lot of things. It's like telling someone, make coffee. They just know all the steps involved. On the other side, you have RISC, or Reduced Instruction Set Computer. This approach uses tons of super simple, highly optimized instructions that run incredibly fast. This is like saying, get the filter, then add the grounds, then pour the water. So what's the trade-off? Well, CISC can sometimes make programming a bit simpler, but RISC is usually smaller, cheaper, and way, way more power efficient. All right, enough theory. Let's meet some of the rock stars. We're about to go on a quick tour of the Microcontroller Hall of Fame to see these ideas in the real world. First up, we have to talk about the legend itself, the 8051. I mean, if you've ever worked in electronics, you know this name. This is one of the originals, and it's easily one of the most popular microcontrollers ever made. A true classic. Intel developed this thing all the way back in 1981. It's an 8-bit chip, and get this, it had just 128 bytes of RAM. Sounds like nothing today, right? But it was a huge deal back then. And it is a perfect example of that CISC architecture we just talked about. The 8051 became a global standard, and its design has been used in countless gadgets for decades. Okay, moving from the classic workhorse to a more modern favorite, a chip that many of you have probably used without even realizing it. Let's talk about the AVR microcontroller. So Atmel came out with the AVR family in the mid-90s, and they went with that faster, more efficient RISC architecture. But its real claim to fame? One specific model, the AT-Mega 328P, is the brain inside most of those super popular Arduino boards. So if you've ever tinkered with an Arduino, yep, you've been programming an AVR chip. Next in our Hall of Fame is the PIC microcontroller. PIC actually stands for Peripheral Interface Controller, and this chip has built a serious reputation for being a lean, mean processing machine. The PIC family, also based on that RISC design, is famous for a few key things. It's fast, it's cheap, and maybe most importantly, it allows for incredibly efficient code. And what that really means is you can get more done with less program memory, which makes it an absolute favorite for specialized, high-volume products where every single penny counts. And that brings us to the undisputed champion of the modern world, the ARM processor. Now, ARM is often a bit more than just a simple microcontroller, but its influence is so massive, you just can't tell this story without it. ARM stands for Advanced RISC Machine. And here's the wild part. ARM doesn't really make chips. They design the processor cores, the brains, and then they license that design out to hundreds of other companies. The result? ARM-based processors are in, well, almost everything. They power virtually every smartphone, every tablet, and every wearable device on the planet. Yeah, the device you are watching this on right now, it's almost certainly powered by ARM. So, okay, we've met the legends, we've learned the lingo of bits and buses and instruction sets. But what's the big takeaway here? Why does any of this really matter? It all boils down to this. Microcontrollers are the invisible engines that make our modern world work. I mean, just think about it for a second. Without these tiny brains, your car wouldn't have fuel injection, your TV would need rabbit ears, and your coffee maker would just be a dumb pot. The automated, connected, and convenient world that we all just take for granted, it simply wouldn't exist without them. And that really leaves us with a fascinating question to chew on. We've put these tiny computers in our appliances, our cars, and our pockets. As our world gets even smarter and more connected, where do you think the next billion tiny brains are going to show up? What will they be controlling for us next?